Every demo video online sells the exact same dream. You press enter, step back, and watch a fully autonomous AI developer spin up an entire application from scratch while you grab a coffee. This chart from the SWE RPG benchmark tells a different story. Look at the gap between the marketing expectation and the academic reality. When researchers tested top coding agents on real-world GitHub issues, they found an average resolve rate of only 31.5%. If you drop an aggressive, shoot-from-the-hip AI into a codebase that requires strict object-oriented discipline, frustration is inevitable. Choosing your setup means looking past the intelligence benchmarks to match the agent's behavioral profile to the constraints of your specific team. To understand these behaviors, we separate AI development into two pieces, the harness and the engine. The harness is the outer shell, reading files, calling tools, and controlling your terminal. The engine is the brain inside, models like Opus 5 or GPT 5.4 providing raw reasoning. Most developers default to a standard subscription, but that locks a specific harness to a single engine. If you're paying a flat rate, you're forced to use their most expensive engine even when running a simple low-stakes script. The alternative is API routing. This lets you decouple the harness from the engine, paying per token for exactly what you use. Routing lets you swap the brain out on the fly. You can point your terminal agent at a cheap 1 million token model to read your entire repository, then switch to a heavyweight model for the actual refactor. That flat subscription limits flexibility to scale your tooling. Matching the tool to the task is critical. We finally have hard data on exactly where agents break down. This diagram from the SWE RPG benchmark paper shows researchers graded AI performance across requirements, planning, and final patch correctness. Looking at the execution sequence, notice requirement analysis and planning. In the real world, developers submit ambiguous requests, forcing the AI to guess constraints. The data shows that 46.7% of all agent failures happen right here, in the planning and requirement stages, long before a single line of code is written. If the agent hallucinates a piece of business logic or misunderstands the target architecture, the code it generates is completely useless. Raw coding ability cannot overcome a fundamentally flawed plan. These planning failures persist because agents either rush the analysis or lack the autonomy to formally challenge a bad requirement. To fix this, you must look at the specific harness architecture. Claude Code prioritizes execution speed over deep requirement analysis. It targets high-velocity prototyping by aggressively patching files to reach a working state. This aggressive bias toward fast action means the agent often skips the architectural due diligence required for complex code repositories. Instead of creating new, modular files for new features, it has a strong tendency to cram more functions into your existing God classes. In its rush to execute, it routinely ignores object-oriented principles, like single responsibility and avoiding repetition. To effectively keep your codebase clean, you have to aggressively manage its context window and constantly babysit its raw output. Claude Code acts like a brilliant but rushed junior developer. It is unmatched for rapid prototyping, as long as you are willing to manage the technical debt. Codex takes the opposite approach, functioning as a high-discipline, high-autonomy alternative. Codex is designed to run in sandboxed work trees, and it adheres rigidly to the constraints and rules you set in your prompt. Instead of rushing to the finish line, it proactively stops mid-task. It will pull back and clean up its own code. The trade-off here is raw speed. For the exact same task, Codex will execute 3 to 4 times slower than Claude. Because Codex adheres rigidly to constraint prompts and isolated work trees, it can handle unattended issue triage across parallel branches without risk of cross-contamination. Codex operates like a methodical senior engineer. You trade iteration speed for rigorous safety and maintainability. Mapping these profiles to your biggest bottleneck makes the choice clear. If you are a solo hacker or a founder, and your primary constraint is sheer output velocity, you need speed. In that case, Claude Code is your harness. You just have to accept the trade-off that you will be spending time later refactoring the architecture. If you are a staff engineer or managing an enterprise team, your primary concern is preventing technical debt and ensuring system stability. For you, Codex is the definitive choice. It's the harness you can trust for unmonitored code integration. Finally, if you are a scale builder dealing with massive, sprawling repositories and tight token budgets, you need a different approach entirely. You need to decouple the harness from the engine. Use an API router so you can feed massive context windows into cheaper models like Muse Spark, keeping your costs grounded. No single agent is perfect. Efficiency comes from consciously choosing which trade-off, speed, safety, or cost, you actually want to make. The AI is just a harness. You are still the lead engineer. Choose the specific tool that respects your codebase's rules, rather than the one with the loudest marketing hype.